This is Mike Krenke with the Sustainable Forest Education Cooperative in Cloquet. It's nice to have all of you online today. We have about 15 participants, ranging from, we have a tribal forester, we have some DNR foresters, we have consulting foresters, and a number of other people online as well. So it's very good to have you online. I want to thank Patty Thielen again for helping to co-sponsor the webinars through the Minnesota Department of Natural Resources Forestry Division. So thank you, Patty. And what I want to do today is go through a couple of logistics, and then I'll introduce Stacey Stark, who is the Director of Geographical Information Sciences Laboratory at UMD, and she will be presenting today on introduction of ArcGIS Use in Minnesota. Well, if you look at your screen, right below my photograph, you'll see a chat pod. So you can type in your questions in the chat pod just by clicking on and then typing your question and then pressing that little brain on the right, and that will bring it up to everyone so people can see what your questions are. And then Stacey will answer them when she's able to answer them. We'll also have a question and answer period at the end of the webinar, so you're able to ask questions at that time. Stacey's presentation will be about 50 minutes. If you would like credit for the webinar, make sure to indicate that right behind your name. If you haven't already, just let us know so that you can receive the 1 credit for the webinar today. So for introduction purposes, Stacey Stark is an MS, has an MS degree, and is Director of the Geographic Information Sciences Laboratory in the College of Liberal Arts at the University of Minnesota Duluth. Is a certified trainer with ESRI. Research involves geographic information analysis in regional sustainability applications, including land use and transit planning, rural community hazard mitigation, and food shed assessment and analysis. Geographic Information Sciences Laboratory pursues both internal and external contracts to maintain the lab and to support projects that provide students with hands-on GIS experience. Stacey educates faculty in the uses of GIS in many disciplines and promotes the use of GIS in the UMD research and in student curriculum. Stacey serves on the executive board of the Minnesota GIS LIS Consortium. So at the end of this webinar, we have a question for you to see which GIS programs you might want in the future that Stacey could help teach, probably beginning next year, or maybe do 1 or 2 a year. So be sure to indicate on that poll which other programs you might want. That will help us to decide which ones we should be offering. So without further ado here, I'll turn it over to Stacey. Thank you for your program today. Stacey?
Thanks, Mike. This is Stacey Stark. Good morning, everybody. I'm going to talk today. I'm going to give you an overview of applications to forestry in ArcGIS, ESRI ArcGIS. And here's a couple of the questions that I hope to answer. The audience I'm expecting today is those folks who have not had much experience with GIS or have staff that use GIS and they need maybe a bigger overview of the direction of GIS, what ESRI desktop is and how that fits into GIS in general. And you probably all can imagine how foresters use GIS, but I will give a little demonstration using some data that you might use, and at the end I'll talk about how to get started, some further training, where you can find online and free courses where you can learn other things as well. Feel free to ask questions as you go along, and I haven't done this type of presentation before where folks are sending in questions, so I'll do my best to answer them. But I was a little unsure of the audience, and so I do want to make sure that I answer your questions, either specifically about the GIS application or more generally about GIS. So feel free to ask questions. So GIS is an umbrella term that's used to describe concepts that you're familiar with that have been around a long time. It's kind of the combination of using database, CAD graphics, and statistical analyses together to incorporate all kinds of spatial data and make spatial decisions, also make maps. GIS is not just the desktop. On the right is a figure of what the desktop will look like, and we'll look at that. But when people say GIS, it really means satellite imagery, GPS, field work, collaboration. It's a lot of things. It's not really just the software. The power of GIS comes together when all the layers of information are combined, and they're tied together in a GIS using a common coordinate system. So you might have information about the vegetation of an area, wetland types, precipitation, elevation. They could come from many different sources, and these layers together, because they're spatially in the same space, you can ask spatial questions. This is just an example of some data from a Lost Creek wetland on the Bayfield Peninsula. I want to point out that there's really an infinite number of layers that we could extract from the Earth. For example, an urban planner might be interested in a layer that's just trees, and we just want to know, are there trees there or not? An ornithologist might be interested in a layer that is trees but has attributes or information about whether it's coniferous or a mixed deciduous forest, and the density of that forest. As a forester, you might need a layer that's trees, but you need to know tree species. You need to know more about the crown closure, the density, the age of the trees. So a layer is really kind of an arbitrary word that's defined by your uses of the information. So it can be at the scale and the resolution that you need it to be. And I mention this because it's important as you're seeking out sources of data that you pay attention to how the data was created and also what purpose the data were created for. So the example of urban planning trees is not going to be very useful to you. This is a simplistic example, but you will see that there's a lot of, as you search for data outside of your organization, there's just so much data that's been created, and for many different reasons, and always not at the same kind of accuracy and precision that you might need. So back to the conversation about GIS being many things more than just software. One definition would describe GIS as a system for the input, the storage, processing, and retrieval of spatial data. We integrate this data together on the computer in a database, but it might come from the field, it might come from satellite imagery. We use the data for analysis and then production of maps, and I'll talk a little bit about how the visualization can be so powerful with the GIS, and that can make for more powerful collaborations with other department members or other organizations that aren't real intimately familiar with what you're working on, but because you can demonstrate that information in the form of a map with some powerful graphics and ways to show the information that are more easy to understand. The analysis piece is also helpful for collaboration because you can simplify something like a complex pattern that you see into a map that you might not be able to pick out from a table. Sometimes statistical tables just don't really tell the whole picture until you can see the relationships in space to one another. So next I'm going to talk a minute about what ESRI ArcGIS is. So again, GIS is the umbrella term. ESRI ArcGIS is the industry-specific software. ESRI is not the only maker of GIS software. They are the dominant player in the area, and as you'll see, ESRI is involved not just with the desktop software, but they also have many applications for the internet, for free browsers, which I'll demonstrate one later on in the presentation, mobile devices. There's application packages so that your developers can use the tools in the software but actually design their own interfaces. So the ESRI ArcGIS system is really much bigger than just one software package. The power of this is that they use a common language in the programming so that all of these things can work together. On the other side of the graphic are examples of where the data are stored and used, and these three on the right and three on the left can integrate in any combination. So on the left we have the different types of software where you might access the software, and on the right the different types of data. And I've given some examples there of what the cloud web services are. You hear a lot about working in the cloud, and what does that mean? That just means that it's not really on a machine in your organization that you can go and touch. The cloud is just all the services and web servers that are out there that you can access, but you can't go physically touch them. A couple of examples that might make this more understandable. The Minnesota DNR has a web mapping service which allows you to access imagery and scan topo maps and historical ortho photos through their server to your desktop. So you don't actually have to store, download, or host that data yourself. That's an example of a service that's in the cloud. ESRI also has similar types of services, and I'll demonstrate some of their base map data that they have that are free for you to use. The enterprise server level is the example of an organizational structure of data that you may have access to, but it's not necessarily all in your own department. It might be a shared server of different organizations. A county GIS is a really good example of this, as is the Minnesota DNR. A county GIS has an assessor's department, a land department, a planning department, and all of these different departments need to have the same base data. So they have one large system GIS and store their data in one central location, but you, even though you're working in forestry, may be able to access the assessor's data for your use. And then the local system is just what you have in your department, on your machine or on your server that you have control over. So again, I just mentioned this because GIS has really grown in the last 10 years. 10 years ago, this figure wouldn't be on your screen. We would be talking about just a desktop application with data that you own and maybe you created and maybe some that you were able to obtain from someone else. Now, you really have the world at your fingertips as far as data access and integration with other departments that use it on mobile devices, that use it on the web. You can share with your clients. You can share with the public through a browser. There's There's all kinds of options. It's very flexible. So let's talk again a little more specifically about how we access data. The mobile devices, the example here is that you or your staff are in the field collecting data. The open standards piece of the application is the coding of the GIS system that ESRI allows your developers to access to make their own programs. The Minnesota DNR has done a lot of this, published their own programs that they have designed, but they use the same basic language that ESRI does so that you can use the same data. You can use their applications as well as ESRI applications. So when you see a custom application, that might be something that's built on open standards. That's what that is. ArcGIS Explorer is a free application that allows you to explore GIS data. It's kind of like LandView, if you're familiar with that. It's ESRI version of a very lightweight desktop, but you don't have to have a license for the GIS for ESRI, and you don't have to even have any of the data. You can just use this through the web. And then finally, the desktop application is what you'll be using at your desk. In the rest of the presentation, I'll be talking about the desktop software, and then at the very end, I'll give a quick demonstration of how that desktop information can be shared to the Explorer on the web. The enterprise integration piece is just that idea of sharing something that you've created on your desktop to share with other departments, again, to share with your clients, or to share with the public through the web. So any of these sources use the common ESRI open source technology, or the programming language, as I said before. So let's take a look now at the interface of the ESRI desktop. This is an example of the desktop. The desktop allows you to access the tables in the database as well as the display of the map. You can find out things like, where is this feature? What is it? By looking in the table. The feature table is connected to the piece of information on the map. So in this slide, you see the polygon of the Balsam Lake fire highlighted, and as we selected that feature in the map, the associated record in the table was highlighted as well. So those two are dynamically connected. You can query a feature using the map or the table. So on the left here, I have an example of a query window where I'm accessing a table for the forest stand inventory, and I am selecting a feature. I write a query that I would like to see this labeled inventory area with an administrative type of forestry. So this query could be as complex as you want to make it here. That tabular information is connected to the map, and so then I have an associated feature highlighted that matches that query. Another way to look at the data is to use an identify tool, which is up at the top of the interface. There's a little eye there, and when I select that and then select a feature, I get that same information, only this time the identify tool is showing me everything in the table for that one feature. So these are all connected, and there's flexible ways to access the data. So the queries are both spatial, using patterns and proximity of features, and informational, using the database. These 4 layers, nesting locations, roads, jurisdictions, forest type, might be used to answer these 4 questions. Where is it? What is it near? the nesting location. Because I have the roads layer tied to the same coordinate system, I have a map that shows the nesting location, but I could run a spatial query that asks, show me the roads within 200 meters of this nesting location. I can also drill down on that feature to the jurisdiction and see who administers this land, because that point is also tied to a spatial coordinate that corresponds with the same coordinates in the jurisdictions table. Likewise for the forest type. A more complex query would be something where we're actually intersecting the data and taking these multiple layers and creating new features from them. A real common GIS example of this is the suitable site analysis, or it could be the converse, a site that's not suitable. We want to look at a place that does not have water, is not greater than 15% slope, and is not on a protected and developed land. We can run these spatial queries that result in new features that that outline the areas that are suitable for that analysis. So we actually create new GIS data in this process. So finally, the visualization piece is the power of the GIS in the desktop also allows you much flexibility in how you visualize the data. And so while people like myself like to say, well, GIS is more than just map making, maps can be awfully powerful tools. And on the left is an example of an illustration of forest land ownership in the United States. And as it's mapped out, you can kind of see at the top, you can kind of see there's more blue in the west, there's more yellow in the east, and that's a powerful illustration in itself. If we want to condense that data into percentages, we can automatically, in the mapping process, choose to demonstrate that information in the form of a chart. And so the chart's actually placed on the map. And you can see how this kind of illustration, depending on what point you're making, neither one is correct or incorrect. They're different tools to show the same information. In the middle, there is an image on the lower end there of Mount St. Helens, and this is a photograph. Now, photographs, when they're completely flat in GIS, are very powerful. Imagery can be very powerful. But in this case, we're interested in the dimensions and the elevation patterns in Mount St. Helens. We could use what's called an elevation model, digital elevation model, or DEM, to illustrate that topography. So that the example on the top is Mount St. Helens, but this is just, all it is GIS data with elevation values that are then modeled to show the elevation, the sun angle, and the illumination of each point so that it actually looks three-dimensional. And you've probably all seen these kind of 3D maps that are usually underneath another more informational thematic map. And this is how it's done. You may know that Minnesota has undergone a really extensive project in LiDAR data collection. And this will allow for 3-meter resolution, which means 3-meter square data for elevation across the Minnesota state. And the LiDAR data will give us this kind of detail in our topography. Really useful for drainage applications and picking out features in urban areas, and super powerful. I understand that there was actually just a seminar last month on the LiDAR data. Then on the right, I've just got an example of some maps that show how an analysis might be portrayed with color, with shading, with circles. In this instance, the imagery is not, the locational information isn't as important as the patterns in space. And so these are also the tools that allow us to collaborate with others and illustrate our information. Do you have any questions at this point? Okay. Next, I'm going to now demonstrate a couple of applications. This image here, I thought this was kind of fun. I was reading a paper on applications of GIS in forestry just to kind of review that, and I used a tool called Wordle on the internet. And Wordle is just a free tool that you can throw in a bunch of text and see what results. And this article, this is what resulted from that text. So the most common words in the text are bigger, and then the ones that are less frequent are smaller. So the most common use, as you all know, is probably the resource inventory, collecting information about soils, tree species, age, type, class, size, knowing where those management boundaries are, survey information, and having this all in one place. These are the types of data that we would use in a forestry GIS. Probably another very common application is using land change monitoring. And this is the application where imagery would probably come in. We have a great fortune in Minnesota to have just excellent GIS resources available at the state level for historic imagery and also current programs from the Farm Services Agency that take good photography of the land. Well, they used to do it every year. I think it's about every other year now. So I'm going to switch now to a GIS application, the ArcGIS desktop. Bear with me for a moment while I figure out how to do this. There we go. Okay. So this is ArcGIS desktop. This is the ArcMap application. And this area here in the middle is just called my data view. And on the left, I've got a table of contents of different layers. In this example, I've got an example from the forest stand inventory of the Cloquet area. I got this data from the DNR, not because the DNR is the only agency in the state, but again, their GIS data was just readily available to me, so this was very easy for me to get on the internet. And then I've classified in this a couple different ways. I've mapped it by the administrative areas, and if I turn off the inventory, oops. You can kind of see that there's some pink areas and some orange areas, not very much else in this. I can also classify this by the survey year. And again, this information that is symbolized, I will quick show you now the properties so that you can see the symbology. I have just taken this value from the database, survey year. I can pick any of these fields in my database. And then I've taken the different years and classified them and given them colors. And I'm going to cancel that so I don't lose my current classification. And the same database is for the administration. These data in the ArcMap, very important point, are just links to my database. So if I look at the source of these data, they are actually coming from a shapefile in my CTemp drive here called FSA cloquet. If I go to this one, it's actually the same thing. So this application is creating a file of settings for my data and keeping track of where that data comes from. And this is why we're able to drag data in from the internet, from different servers. We can copy, as I did with the forest stand inventory, the same data set over and over and display it in different ways. And it's not clogging up our database because I haven't duplicated any data. I've just been displaying it differently. I'm going to zoom in now to some soils data, or let's see, got the forest stand survey year, and now I'm going to show you the soils data. Now, pretty intuitive. On the left of table of contents, I can just click on and off my layers for visibility. So when I want to see that inventory administrative boundaries, I can use that one on top. I can check it off for the forest stand inventory and check it off for the Servo. These are also drawn in the order that they are listed in the table of contents. So if I drag my soils up to the top, it's now underneath my survey year. I might want to use this base map that I have here. I'll turn that one off so you can see this base map here. I might want to be able to see those roads a little bit better, so I can also just use some transparency. I'm going to make this more transparent so I can see it better. Whoops. Okay, so lots of flexibility just in your interactive display area here. All right, I'm going to demonstrate that identity tool. Turn back my forest stand inventory. This identity tool here, I want to click on one feature, and as I click on that, for this administrative area, I'm getting the full record of contents of that corresponds with that polygon. So this full database is associated with that. Now, if I were to do the same thing with the select tool, I'm going to take this select tool here and select that polygon. It becomes highlighted. And now, if I go to the forest stand inventory, whoops, do this one, and open the table, I have one record that is selected out of 8,706. And this is the record that I'm currently highlighting. So this is the same information as this table here. And both of these can be used for editing, which is, obviously beyond the scope of this seminar. But this is how, if I just want to make a quick change, I can access the information visually, spatially, and then go into the table. Okay. Now, next I want to show you this idea of selecting by attributes. I'm going to go to my forest stand inventory, and I'm going to find all of the areas that were surveyed. In 2011. So I find survey year equals, and just to be sure, I'm going to find, there we go, 2011. So I've just created a query here, apply that, and then I have a selection that's been created from my query of the database. I can open that table again, and now I have 185 out of those 8,000 records that are selected. It can do things like go to the area. This is in square meters, but let's say that I want to find what the sum of the area is. I can use this number. And this is something you can also calculate in a more useful unit, but just for example purposes, you have access to some statistics and summary, quick summary tools right here. Okay, I'm going to show another example where I'm interested in this same area here, but I'm interested in, let's see, I'm interested in this nesting location that I found. So my technician has gone into the field and he has, with his GPS, recorded the coordinates of a nesting location for an eagle. So I'm going to go and I'm going to take my XY tool here and I'm just going to type in the coordinates. And I haven't pointed out yet that in the lower right-hand corner, we also have coordinates here, latitude and longitude in degrees, minutes, and seconds as I move my cursor around. Now, another option is I could change this to a UTM coordinate or whatever other unit I please, but I can interactively see how the coordinates change. But if I want to find a specific coordinate, I might use this XY and select Enter, and then you could see how that point, as I selected Enter, was flashed. That flashing was a little too quick for me, so I'm going to add a little call out here. And now my point has been saved to this location. So now I've got a point. Oops, yes, now I have a point that's associated with these coordinates. And the next thing I want to demonstrate is that I can share this information. So again, this is at my desktop. This is a really simple example. I just have one point here. But let's say that I have someone across the state that I want to share this information with, and they don't have a GIS application. They don't have an ESRI license. So what I'm going to do is I'm going to create a point right where that location is. I created a feature right here, and then I'm going to go to my next application, which is ArcGIS Online. I'll go back to the starting page here. So if you type in this arcgisonline.com, you're going to get to this area, and I have logged in already. In order to create a map, you need to have a login. It's just a free login. If you want to share something only with a certain person, they also have to have a login so that you can share only to them. But if you want to just make something public, they don't have to have a login. I have a few different things in my content. I've created a map of the Flute Reed River. Okay, this is up on the North Shore, and I've made a custom map with their custom 6-inch pictometry data. So the base map is actually their imagery, and this might take a minute to load, but as I zoom in, you can see there's really nice resolution. And again, this is just a free viewer. I've just loaded this in, and I've loaded in some other data here. There's survey data and the Superior Hiking Trail. So this is an example of a map I've created. Now, my example of the nesting site, I just want to make a new map. And I'm going to just open up my application, and I've got just this general base map of the world. I'm going to click on base map, and let's see, the one I was using in my ArcMap application was the National Geographic one. And if I zoom in, I'm just dragging over and scrolling in. And the nice thing about using these online versions, they're actually faster than your desktop because they're so optimized with the data at different scales. So as you zoom in, you get more detail. It's very fast. Okay, so I've created this. I'm going to add from a file, I'm going to add my area 251, which is the polygon of that area that I was interested in. And then I'm also going to add that nesting point. Okay, while we're waiting for that, let's go back to this because I did forget to show you one thing here. I had selected this area and I want to share this one polygon as well with my colleagues on the other end of the state. So what I did was I took this one polygon and I just went to the layer that it came from, selection, create layer from selected features, and I just get a new layer that shows just that one feature. So now I can turn that one off, and I have this new polygon that I can symbolize and show however I like and share that. Okay, let's see if my thing has loaded. Yep, there it is. Okay, so I have loaded that, and then I want to load the nesting site, which should be a little quicker. So add layer from file. I did have to zip these first. And if you have any questions about the details of how I did some of this, because this is such a short seminar, feel free to contact me afterwards, and I'd be happy to share the details with you, because this is all pretty fast. Okay, I want to import that nesting site. And when this is done, are there any questions? There we go. So I'm just going to zoom in here. Okay, so now on my map, I've got a base map that I was just provided from the free versions. I added some of my own data from a file. I then went to details here, and I have a table of contents. So my nesting site, I want to configure a pop-up so that I can get some information. Okay. And now when I click on that, I can get the information from the table showing up. Now, again, this is the map that I might want to share. So I'm just trying to get the map to look just the way I want it. And you know, this base map just isn't really that great at this scale, so I think I'll just change that to imagery. There we go. Okay, so now I just have the imagery showing, and let's make this outline so that it's hollow. There we go. And I have the ability to change the transparency, the output width. Okay, that's better. So now this is the example that I want to share with my friend. I'm just going to click share. Whoops, I need to save it. Okay, save it. Nesting site. And now I can share that. I can share it with everyone. I can also have groups created with certain members. And all I need to do now is take this thing here, and I'll just, for fun, I'll paste it into your browser there so you can see that. And now anyone can open this and see it in their own browser and interact with it. You can zoom in and out. You can click and get information from the table. We can click here. So at the risk of sounding like an ESRI cheerleader, which I don't want to at all, they are the industry leader. They have a lot of great tools. But this is, ESRI is really breaking ground in the future of GIS, which is all about collaboration and sharing. And these tools are going to be so common in the future. And again, you may not be the one who is using the GIS at your desktop. You may have just technicians or colleagues that use GIS, but you will want to know how to interpret spatial data and also just the power and tools that are involved with GIS so that you can ask for different maps, you can ask for different queries, you can recognize the power of sharing maps and imagery with folks. It really is becoming quite commonplace. I'm going to switch back to my slides if I can. There we go. Okay, so let's see, I have a couple more minutes. Another example, here's just a few other examples of ways that forestry is, or forestry management is conducted using GIS. Timber harvesting, finding wood supplies, fuel wood, fire management, multiple use management with snowmobiling, logging, trails, waterways, you name it. So all of these things, again, are integrated maybe from other departments that you can access commonly in the GIS. I just want to share a few resources with you here. The top one is the online mapping tool that I used, ArcGIS Online. And this is also just kind of like a MapQuest or a Google Maps tool. So if you don't have to have your own data to share like I demonstrated. You may just want to look at your house or make a map of your running route for the day, and you can use that. So I would encourage you, if you don't use desktop or aren't planning to use desktop, explore a little bit just on that ArcGIS Online site. ESRI is also, I don't have that link on there, just www.esri.com. They have a whole suite of online training modules. If you're connected with a university or I think the state agency as well, there are many of those online courses that you can access through the state license at no cost. So if you just have 2 hours and you just want to learn about making a good map and how to add scale bars and how to choose colors and that sort of thing, there's a demonstration for that. If you want to learn more about some of the language like layers and geodatabases and coordinate systems and some of this lingo that we use in GIS, there's a lesson for that. So ESRI has a whole host of lessons that you can work through, data that you can use as samples and resources there. The Minnesota Geospatial Office also has, this third one, has a training site, and they list not only the ESRI trainings that are coming up, but also training that's available through the Minnesota GIS LIS Consortium, which is an organization for GIS professionals in the state and also to foster new GIS professionals. We have workshops hosted in the spring and in the fall through that consortium that are very low cost, and we try to rotate the locations, so sometimes they're in Duluth, sometimes in St. Cloud, sometimes in Minneapolis, Rochester, and that's another good idea to attend. We have a big conference in the fall in October that's attended by about 500 people, and if you're just interested in seeing more in depth about actual applications of GIS and how people are using it around the state, or to get state updates on statewide data initiatives, that's a terrific conference to go to. It's very well put together, very well attended. The MinGeo site also has the clearinghouse of data for the state, not just the Minnesota DNR, but also like state demographic data from the Secretary of State's office. There is a repository for aerial photography, also for the LiDAR data at this MinGeo site. And these resources, not all the training, but these data resources that I'm mentioning are all free. So it's truly amazing what kinds of data are already out there. And then I've listed my site here for the Department of Geography. We have a GIS minor, a GIS certificate, and soon we'll have a GIS major for undergraduates. And I mention this because there are oftentimes when we're looking for folks to come in and talk about how GIS is used in their industry. There's often professionals that come back and take workshops from me or semester-long courses in GIS in different topics. We have remote sensing classes. We have basic database, GIS database types classes where we really get into the data formatting and geodatabase formation. I teach a class a couple times a year, which is the Intro to ArcGIS Desktop, which unlike the seminar, we actually all get into the software and can access the tools, and it's a 3-day long course where you go through the desktop software and get an overview of how to use the software as well as GIS. And I usually host that in January and in August as an ESRI certified trainer. So it's 9:51, and I'd be happy now to take any questions.
So those of you that would like to offer questions, if you have any, please type them up in the chat pod, and then click on to the upper right icon, and Stacey can answer. But I want to thank Stacey. It's great to have a person with your expertise of teaching, understanding the program of GIS, ArcGIS, and offering it to our larger professional audience. I really appreciate it. And Stacey is able to teach other courses in ArcGIS. We're going to do a survey question right now. And Christian from Iowa State University is putting up the question. I'd like you to click on the check marks there on the left, which programs you would like us to offer the SFEC in the future with Stacey. So please do the survey for us, and that will help us out. I appreciate it. Stacey, do you want to talk a little bit about these 1, 2, 3, 4, 5 different programs?
Sure, and just to clarify, some of these, there may be someone else more appropriate to teach them, particularly the Minnesota DNR specific courses. We talked a lot about the content of this course and agreed that it needed to be really an overview for folks that weren't as familiar with ArcGIS, and that some of these topics would be worthy of a full seminar and audience that was specifically interested in them. So that's why we're offering now other things. So in an ArcGIS 10 class, I would start kind of where we left off without the explanation of an overview of GIS and different GIS applications and how they tie together, but more specifically about the interface and some of the tools in the interface and just that demonstration piece. The land view tool is a online. I don't actually use it, but I I just know that that's something that Minnesota DNR folks have developed primarily for their non-GIS users to access their GIS data, similarly to how we did with ArcGIS Online. And they also have something called Quick Layers that I use here at the university to access their data very readily, not by downloading it through the DNR Data Deli, but actually having it hosted on their server. And if you have that ability to connect through the DNR data, there could be a specific class on their data. I could do another class on the ArcGIS Online, so some of those specifics about how to take data from your desktop and compress it and then load it to a map, and making maps that you can share and setting up groups and that sort of thing. And then GPS, I know, is a real interesting area for foresters because it's used all the time. I would mention too, the class that I would teach would be taking that GPS data from the field and then from the point of plugging it into your computer, and how you can bring that into ArcGIS and use it. Now again, if GPS, using a GPS is something of interest to you, or using ArcPad, which is the ESRI application that can be loaded on a mobile device, those kinds of workshops are hosted through the Minnesota GIS Consortium at a really reasonable cost, a couple times a year. So the consort, I didn't put that on there, but if you go to the Minnesota, the MinGeo state training site, they have another link there to the consortium website that will list all the workshops and when they are. For those real hands-on, I would recommend getting to a class where you can actually go in the field and use the unit. And if you're interested in that sort of thing and how to create forms. Okay, Mike, we just had this question about, will the webinar be available again? And
right.
Yes.
Yeah. Okay, I can answer that. On the SFEC website, on the upper left-hand corner, there's a link that goes to past webinars. And all the webinars that we've done with SFEC are archived through Iowa State University. So you can just scroll through them and then click on the one that you would like to listen to. So yes, it's available to anyone at any time. So after the program, Kristen with Iowa State University will archive this webinar from Stacey, and it's available to you and to others. So, and then I see the poll is pretty evenly split, although Minnesota DNR data content and accessing received 8 votes and others received 6. So we'll have to have a discussion with Patty Thieland and see what she would recommend as well. And if you have other, if you want to do any kind of lobbying, either with me or with Patty, just let us know, or Stacey. And Stacey, I really want to say again, thank you for an excellent webinar and sharing your expertise. And it's nice to have you close by as a resource in Northeast Wisconsin, and offering these classes that you're also talking about. So I appreciate you sharing today, and wish you well with your classes, and we'll be back in touch. Before I close, I want to say there's a few more programs that are coming up of interest. Our next webinar, March 6th, with Mike Kilgore, professor with the University of Minnesota, Department of Forest Resources, incorporating economic criteria in forest management and planning. And then Dick Rossman, who is going to do the program today, is still working on the forest management guideline audit update, so it was scheduled for April 10th, or rescheduled. And we have 2 big programs coming up. The one in February 21st, Adaptive Management in the Face of Climate Change. This will be a really interesting program as well. We got 10 presenters, Tony D'Amato, Lee Freilich, but others from out of state. Louis Iverson, who wrote a manual on the biggest winners and losers with trees and birds with climate change. We'll be here presenting. We have the climate change people from Houghton Hancock will be here. The Nature Conservancy, Brian Palick is going to be presenting as well from Grand Rapids. It's going to be a really, really excellent workshop. So be sure to sign up for the February 21 Adaptive Management in the Face of Climate Change. And then one more announcement. On March 22nd, we have a major program on what is a healthy forest. So DNR are taking leadership to organize this workshop. Val Cervenka, Mike and Jana Albers, and Sue Burks. So we're talking about diseases, insects, but also invasive plant species. So it's going to be an excellent workshop also at the Cloquet Forestry Center. So if you have any questions, give us a call. Kathy LaPlante in my office is helping us with some of the work that needs to be done here. Or give myself a call. And we certainly appreciate you being online today. And again, Stacey, thank you very much for your program, and I will state Kristen for helping us today.
Thank you very much.
Okay. Okay, I think we're done. So we'll close out and hope to see everyone at our next program coming up. Goodbye now.
Okay, bye-bye.